All right, so today we are doing 5-6, which is, we're finally getting to that direct and inverse variation we talked about in enrichment. All right, so we're going to find the constant of variation, work on that for direct and inverse variations. We're going to identify some relations that are direct or inverse. We're going to write and apply some function rules for direct and inverse variations, which we did yesterday. And we're going to solve some real-world problems modeled by direct and inverse variations. So first up, direct variation. Okay, we use a k to represent the direct variation. Okay, so it is also a function in which the ratio of the variable is a non-zero constant, k, and that is, if you notice, y divided by x equals your k. It's always your y value divided by your x value will equal your k, your constant there, your direct variation. So quantities are said to vary directly, which means they're directly proportional. So if something is 1/2, that's directly proportional to having measurements of 3/6. Okay, they're directly proportional. So k is the constant of variation, and it's stated as y equals k times x. Okay, y equals k times x, or f of x equals k times x. Okay, is how we can get that. So we've got our k, notice again, our k is the y divided by x equals k. We can find our y if we multiply the k by our x. Okay, we're just manipulating that. Do you remember literal equations when we solved and they just had lots of variables in them? That's all it is. In the direct equation or direct variation, remember we talked about an increase in one variable, right? An increase causes another increase in the other variable. We looked at graphs like that. We talked about some of those, a lot of those examples. So example 1, does the table represent a direct variation? If so, find the constant of variation and write the function rule. So are these numbers going up? 1 to 2, 2 to 3, 3 to 4? Yes, they're increasing. Are these numbers going up? 7 to 14, 14 to 21, 21 to 28? Okay, so this side's increasing, this side is increasing. Is that a direct variation? Yes. Yes, it's a direct variation because an increase causes an increase, if I could write today. All right, so then how am I going to find the constant of variation? First of all, what's my variable for constant of variation? Man. Okay, so you're not listening to my question. What is the variable for the constant of variation?
For every increase by 1 in x, there's an increase by 7 in y. But I don't know if I answered your question properly.
Nope. What is the variable that represents the constant of variation? That is my question currently. I'm just looking for a variable. That's all. I don't want a number. What is it? K. The constant of variation is K. K equals the constant of variation. Okay, so I'm looking for my K value. So K equals, how do I find my K? Okay, y does equal kx, yes. And so we can do that. That's one option. Okay, we also had it up here, and it got marked out because I ended up marking it several times, trying to point you there, that k equals the y divided by the x. Okay, so to find that, we simply say, like, let's pick a different one maybe besides that. We'll take our y value is 14. We divide it by our x value, which is 2. What's 14 divided by 2? 7. So what's my k? 7. My constant of variation is 7. Now that's not to say you can't use this. You can. Okay? But in this case, you would say, well, my y is 14. That equals my k times 2. I would have to solve to get k by itself. And so I still get 7 equals k. So it's not that you can't use that one. Okay, I've given you both versions, both forms of it, like how you're going to apply it and how you're going to use it or find it. Okay. So example 2, find the constant of variation if y varies directly with x and y equals 6 when x equals 3. Write the function rule for the variation. Okay, first of all, it is extremely important that when you're reading this, you're picking out some keywords. Okay, right, we're going to find the constant of variation, which is k.
And we have to find the function rule, so we have to use the f of x one.
Okay, so function rule, so we're going to use f of x. There's one more keyword in here. Okay, so what's one keyword? Just one. Not variation. Nope, not varies. Directly. Okay, because we're talking about direct variation and inverse variation. So the fact that they're telling us it varies directly is the key. Okay, because inverse is going to be different. All right, so we're finding that constant of variation, k, and we know k equals what?
y divided by x.
Okay, so we've got our formula, and we know our y is equal to what?
6.
6. Okay, when x is equal to what? 3. And so that would be 2. 6 divided by 3 is 2. No, she said that would be 2. Okay, so our k is 2. And now we have to write the function rule. That goes back to that. What's the function rule? F of x equals what? Kx, right? That's, you should probably write this down. Okay, so we're going to use that function rule. So f of x is going to equal what? We just solved for our k. Not 2 times 3. That's not a function rule. That's one example. It's going to be 2 times x, because we want to be able to play in what you just said would be f of 3 equals 2 times 3, which is 6. Okay, so that we want the equation form where we have f of x equals, and we're using an x, so we can plug in any number we want for x. Okay. Questions about that? Sweet. All right. So then we've got when two quantities vary directly, their ratio is constant. So if they vary directly, their ratio is constant. Okay. And you can do this for 2 different ordered pairs. So if you have, it says for 2 different ordered pairs, notice we have x sub 1 and y sub 1. That's for our first one. Our other ordered pair, x sub 2, y sub 2. Okay. We would take the y and the x from the same one and divide them and get our k. The y from the second one and the x from the second one and get our k, and the k is going to be the same. It'd be the same up here with this problem. If we had chose 21 divided by 3, we still got 7 for our k, right? It didn't matter. If we chose 7 divided by 1 to get 7, the 14 divided by 2 gives us 7, the 21 divided by 3 gives us 7, the 28 divided by 4 gives us 7. That's why it's called constant. Right? Doesn't matter which ordered pair you pick, you're going to get the same constant of variation. Yes, ma'am?
Would we be able, so do you have to do it that way, or could you use like y1 divided by x2?
No, you have to do y1 divided by x1. Yeah, so you have to pick the ordered pair that goes together. Otherwise, it won't work. Good question. Good question. Let's see. So sometimes that will be helpful because we say they're directly proportional. So sometimes it's going to be helpful to set up a proportion to solve them. So notice we just said, well, our y1 over our x1 has to be equal to our y2 over our x2. Okay, so we set up a proportion instead of solving for k. And that's going to be super helpful on problem 3. Okay, so let me try to change this. So in example 3, Still got that. Okay. If the distance traveled varies directly with time and Jose rode 12 miles in 45 minutes, how far can he ride in 2 hours? So, in the first one here, we're going to set up a proportion. I was like, why am I flashing? It says, hint, use a proportion. So, D sub 1 over T sub 1. What does that stand for? Those D and T's? Distance and time. Absolutely. Okay, so what's my first distance? Jose rode 12 miles in 45 minutes.
12 miles.
Okay, so I've got, and I don't have to put the miles even, right? Like I don't, so I'm going to have 12 over, what's my time? 45. Okay, equals my second distance over my second time.
Would the distance be, we don't know the distance, so it'd just be D.
It'd just be D. Okay, so we would just have D over, and what's my time?
2.
Okay, now this is no, you're good. This is problematic. What's problematic about these?
One of them.
I did not hear you.
One of them is in minutes, the other one's in hours.
One of them is in minutes and one of them is in hours. If I put a 2 here, that's going to be 2 minutes.
120 minutes.
Correct. That's the key. Like you have to remember, like, oh, this is 120 minutes. So again, it's like when you're looking and reading, like thinking through all the parts and pieces, like we've got to get them in the same unit of measurement. And then how do we solve a proportion then?
12 times 120 equals 45 D.
Good, right? We do the cross products. Okay, again, you don't even have to multiply. You could just go ahead and divide by your 45 if you wanted. So what does D equal?
32.
Anybody confirm 32?
What?
She said 32. I said, does anybody confirm 32?
Because 12 times 120 is
144, so
144 divided by 45 is 32.
I'm still waiting for someone to confirm that. How are you confirming that? Do you have math on your paper?
32.
Okay, I was like, did you use a calculator? Like, are you sure about your... Okay, so we got 32 miles at that point. I'll put my miles in there. There's an MI, but it kind of disappeared. Yep.
On our homework assignment, would you want the 2 answers, or just because it says example 3 it says use a proportion or find the constant variable, so choose one of those or do both of them?
In the notes, I'm going to show you both.
Okay, so it doesn't
And so,
on the paper.
it does not matter. You can choose. Yep, you get to choose your method. I would recommend practicing both methods, though. Don't just do one. So then the other option is we can find the constant of variation. So, I don't know. I was just wondering that myself, why there was a blue square. But I got nothing for you.
It got bigger.
I don't know. The timer's still going. There it disappeared. So anyway, so how would we do the next one with finding the...
What is the distance and the rate?
You know what your distance is, right?
Yeah.
The distance is 12 miles.
Right, it shouldn't be rate, it should be time. I was a typo. Sorry about that. Okay, so what's my distance?
32.
No, you solved that already. You can't use 32. The distance is 12.
Divided by, would we do 120 or would we do 45?
Okay, well, what goes with the 12 miles?
45.
The 45. Okay. So
Okay.
equals K. So what is 12 divided by 45? What was it?
0. Do you want the decimal or the fraction?
I would rather have the fraction.
Okay. The fraction is 2/7.
2/7. Anybody confirm that?
What? Why?
It's the blue box is fine. No. Anybody confirm 2/7?
No, because
No, because you have to do the 12 first and then the 45.
Yeah, 12 divided by 45.
It's 12
Yeah, but So that means that 12 is divided by 6 would get me 2 is 45. I was like, 6 won't go into 45.
That's what I'm saying. And then it wasn't, but that's what I was thinking.
4/15.
Okay. Okay. All right. So then what do I do with this 4/15ths? Because that obviously is not 32.
Reduce it.
We can't reduce it. They don't have anything in common. That's what you just told me. No, you're good. I'm just saying. I mean, we could do 2 over 7.5, but that's not helpful. Okay, see, that's the thing. I found the constant. I said, what do we do like now? Because all we found was a constant of variation. When we solved here, we found distance. When we solved here, we found the constant of variation. That we didn't solve the problem. How do you do that? How do we use the constant to find the distance? We can't use 32 yet. 32 is the answer. We know it's going to be the answer. What was the other formula we had with k in it?
Y2 over X2.
Y equals kx. Okay, well here's the problem. Which one of these is y and which one of them is x? The d or the t? The d is the y, like it's in the numerator, so it should be. So then we need to change this equation to say this should be d equals k times t. Okay. So now how do we solve that? Is that our, do we need to use a 4/15? That's the k. Okay, so yeah.
So D equals 4/15 times 2 hours, 100 minutes.
Okay. So which of the, we have to know one, either the d or the t, and plug in a value. But we're trying to solve for the d, right?
So then we need to do the t, which is 120.
Yes. So we're going to have d equals 4/15 times 120. So d equals
480 over 15.
correct.
Which is
Because it should be. We're solving, right? We're solving the same problem.
I was very confused.
Okay, we're solving the same problem. We should get it. So which of these is easier?
I would say the proportion, but I think
Right. The
variation is, it calculates it out, so
it all depends. Can we
I
just
see.
finish the notes as homework?
No.
Oh.
So yes, the proportion is actually easier, but sometimes you need to see both methods to understand. All right, so the homework then is for tonight is just numbers 1 through 13 odd as well. We'll cut that back and we'll finish up the lesson tomorrow.